Greeting learners, so we're gonna continue the session. Remember we did stop at question 9 of paper 1. So now we're going to take the last question and this will be question 10. Question 10.1. A and B are independent events. The probability of A is equal to 1/3 and the probability of B is equal to 3/4. Determine 10.1.1 the probability of A and B. That is the first question. So let's respond to this first question. Event A and event B are independent if the outcome of event A has no influence on the outcome of event B. So meaning the occurrence of event A has no effect on the probability of event B. So we're going to have the probability, but this is practically the solution. Term 1. The probability of A and B will be equal probability of A multiplied by probability of B. And then we're going to have 1/3 multiplied by 3/4. And if we simplify 3 by 3, our answer will be 1/4. So the probability of A and B will be equal to 1/4. Then we're going to go to the next question. Is the probability at least one event occurs. So here we will need some space. So I'm going to clean the board just here, and then we'll have some space for this question 10.1.2. Okay, so we're going to the next question 10.1.2. The probability of at least one event occurs. We're going to answer here is a 10.1.2. So it will be probability of A or B will be equal to probability of A plus probability of B minus probability of A and B. And this will be equal to 1/3 plus 3/4. We got already the probability of A and B is 1/4. So what are we going to add here? So I'm going to use my calculator. We'll be having 1/3 plus 3/4 minus 1/4. And the answer is 5/6. The answer here is 5/6. So this is the probability of at least one event occurs is 5/6. So I'm going to clean the board now and we'll be going to the next question because we have covered 10.1.1 and 10.1.2. So we're going to clean the board and go to the next question. All right, so here's the next question is 10.2. The probability that it will snow on the Drakensberg Mountains in June is 5%. When it snows on the mountains, the probability that the minimum temperature in central South Africa will drop below 0 degrees Celsius is 72%. If it doesn't snow on the mountains, the probability that the minimum temperature in central South Africa will drop below 0 degrees Celsius is 35%. So here's the question down. 10.2.1. Represent The given information on a tree diagram clearly indicate the probabilities associated with each branch. So here's the solution. They are talking about a tree diagram here. So let's see how we're going to have a tree diagram. The probability that it will snow on the Drakensberg Mountains in June is 5%. So then we're going to have this snow and 5%, 0.05. And down here is going to be no snow. To make it 100% or 1, we're going to have here 0.95. Remember, each and every time we must have 1 unit. So we are continuing with our tree diagram here and there. So let's consider this to be B. Down here is going to be not B. They are saying the probability that the minimum temperature in central South Africa will drop below 0 degrees Celsius is 72%. 72%, we're going to write it like this. And to make it 100% or 1 unit, here we're going to take 1 minus 0.72, then we get 0.28. For this option also, we're going to have this 3 like this. Here it will be B, and down here is not B. The probability that the minimum temperature in central South Africa will drop below 0 degrees Celsius is 35%. So here we're going to write 35% is 0.35. To make it 1 unit, 1 minus 0.35, we're going to get here 0.65. So here is our tree diagram. Clearly indicate probabilities associated with each branch. This is what we are having. This is practically the answer for this question 10 to 1. We're going to go to the next question, and let's clean the board, and then I'll write the next question. Okay. All right, so here's the next question is after 10 to 1 is 10 to 2. Calculate the probability that the temperature in central South Africa will not drop below 0 degrees Celsius in June 2024. So let's go to the solution. The probability of not below 0 degrees Celsius, it's going to be equal to the probability of snow, as we are considering here. We're having already calculated the probability using this tree diagram. We're also going to need this. So the probability of snow not below 0, not below 0 degrees Celsius is going to be plus the probability of no snow and not below 0 degrees Celsius. So this is what we're going to have here. We need this tree diagram, so it will be 0.05 multiplied by 0.b, 0.28 plus, and here not snow not below 0 degrees Celsius, then it's going to be this one down here, 0.95 multiplied by 0.65, and this will be the probability at least not dropping below 0 degrees Celsius. We need to use a calculator to get this value. 0.05 times 0.28 plus 0.95 times 0.65, we getting the final answer is 0.6315. So this is the answer for question 10.2.2. The probability that the temperature in Central South Africa will not drop below 0 degrees Celsius in June 2024. So we're done with this question. We still have got some sub-questions. I'm going to clean the board and write the next questions. Okay, here's question 10.3 now. 10 learners stand randomly in a line, one behind the other. First sub-question 10.3.1. And how many different ways can the 10 learners stand in the line? That's the first question. Let's go to the solution. 10.3.1. So we're having 10 learners. They're saying they stand randomly in a line. So how many different ways can the 10 learners stand in the line? Is going to be like this. So the answer here will be factorial 10. This is the answer for question 3.10.1, because they will be standing in a line, and this will be different ways of these learners to be standing in the line. Now we're going to the next question. This is 10.3.2. Calculate the probability that there will be 5 learners between the 2 youngest learners in the line. So we still have got 10 learners, and they are going to be standing in the line. How are we going to calculate here the probability that there will be 5 learners between the 2 youngest? So if I consider all the learners standing in a line, we're going to have 2 times, when we consider 2 out of 10, we're going to remain with 8 times 7 times 6 times 5 times 4. Here's 1, 2, 3, 4, 5, 6. And then here will be 1, because they are saying there will be 5 learners between the 2 youngest. So here we have got 1, 2, 3, 4, 5. And then to continue here, we will be having 3 here, 2 here, and 1 at the last. If we try to check the number of learners here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. As you can see here, we are talking about the concept of factorial. What's going to happen here? We'll be having, for 5 learners, if 1 learner is going to stand in a position, these other 4 will be rotating. And if that first one will change the position, the other 4 will continue to rotate. So we're going to have 4 possible starting positions. We will be having 4 possible starting position. If we consider this way of learner standing, how are we going to write it using factorial? So it's going to be 2 multiplied by 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 is going to be 8 factorial. Now talking about the 4 possible starting position, we're going to multiply this by 4. So it will be like this. And how much are we going to get here? This will be the total number of possibilities. Let's use our calculator. 4 times 2 times the factorial 8. We're getting 322,560. This is the total number of possibilities. We can write it here, total number of possibilities. Total number of possibilities. Now, responding to our question 10.3.2, I'm cleaning the board just here on top so that we can finish up with this question. We need just this space here because we have already responded to this question. The probability, finishing up with this question, the probability of 5 learners between the two youngest, so I'm going to write here in between to make it short, is going to be equal to the total number of possibilities over the number of the 10 learners. Remember for the previous answer, so we're going to have here 322,560 divided by the sample number, and this is going to be divided by factorial 10. This will be the probability that there will be 5 learners between the two youngest learners in the line. Yes, I have shown it here. Between the two youngest, we have got 1, 2, 3, 4, 5. This is being the total number of possibilities, and the probability of 5 learners in between will be equal to this total number of possibility over the sample number. So let's do the calculation and get the answer for this. This will be practically the final answer for this question. 322,560 divided by factorial 10. What is it going to be? So we're getting here 4 over 45. This is the probability that there will be 5 learners between the two youngest learners in the line. We are done with question 10. So with this, we have practically covered paper 1, Mathematics 2023. We're going to consider a next session where we'll take now paper 2 of the same year, 2023. So we are done for now, and we will continue to a next session. Thanks for watching. Don't forget to subscribe, like, comment, and share the video if you learned something. Thank you.